Hey Math 1, this is Mr. Owsley. I've got the first video of the school year waiting for you right here. Section 1.1 starts out a chapter that's basically me saying, here are the pre-algebra skills you've learned in previous math classes. Let's apply them now to just a little more rigorous math. What I'm asking you to do in this first lesson is to place these numbers on a number line without using a calculator. And I've got some very specific strategies that I want you guys to practice and really commit to memory. So let's get to it. So our first example, 10 over 19. The first thing I want you guys to be able to do is recognize this is close to 1/2. It's really close to a half. You know why it's close to a half? Because 10 over 19 is close to 10 over 20. And I think most of you guys could agree like 10 over 20 is easily recognizable as half. So, is 10 over 19 bigger than a half? That's our symbol for greater than. Or is 10 over 19 less than a half? Because bigger than a half would mean it would go slightly to the right of this spot on the number line. Less than a half means it would go slightly to the left of it on the number line. Well, we can say right away that it's going to be bigger because 10 is bigger than half of 19. 19 cut in half is 9.5. That's what equals a half. 10 is bigger than 9.5, which means it's got to be bigger than a half. And I think some of you guys can just see that right off the bat. Like if I'm shooting free throws in a basketball game, if I make 10 out of 19, I'm shooting more than 50%. It's usually an easily recognizable thing. But this is one way in which you guys can for sure figure it out. It's bigger than a half because 19 is smaller than the 20 that needs to be half of 10. So, all right. We're checking A off the list, and we're making sure that we actually point it out. That's A. So, recognizing close to a half, bigger than or smaller than. Second one. This is pretty interesting. Anything divided by 11 has a very specific pattern. The first thing I want to do, though, is convert 47 over 11 into a mixed number so I can see what the actual number is divided by 11. So, if you guys remember, you're just figuring out how many times 11 goes into 47. So 11, double it, 22, add another one, 33, add another one, 44. So this would be -4 because 11 times 4 is 44 with 3 left over. So be able to turn a fraction into a mixed number. That's an important skill that we have today. Here's the pattern with the 11ths. 1/11th is equal to 0.09090909, and it pretty much repeats that pattern forever. 2/11ths is 0.1818181818 forever. 3/11ths, and let me move this thing a little bit further down. Give us some space here. 3/11ths is 0.272727. Do you guys see the pattern that's happening here? 9, 18, 27. What would the next one be? 36. Yes. For some reason, the 11ths share this pattern of all I got to do is multiply the top number by 9, and that's the number that keeps repeating. So 5 out of 11 would be 5 times 9, 45454545. 6 out of 11, 6 times 9 is 54. So 0.545454. And this pattern just keeps continuing on and on and on. So -4 and 3/11ths is -4.27 repeating. So to plot that on a number line somewhere, I got to go all the way left, because we're talking negatives, all the way left to -4 on the number line. Okay, I'm at -4. Now I'm going 0.27 in the left direction. So what's this right here? Well, that's exactly smack dab in between -4 and -4.5. That's -4.25. 4.27 negative would be to the left of that. So that's where B would be. Okay? -4.27, left of the quarter mark between -4 and -4.5. So this is a pattern I want you guys to commit to memory. The 11ths mirror the pattern of times 9. So then if I said, what's 8 divided by 11? You guys would instantly say 0.27, 0.72 repeating. All right. Let's place letter C on the number line. All right. 1 7/9. Okay, so we talked about the 11ths. We talked about being really close to half. 7's not exactly half of 9, and it's not one of the 11ths, but it does have a pattern. 1/9 is 0.1 repeating. And it just keeps going on forever. We could just write it like this with over 1. 2/9 is 0.2 repeating. Or 0.2222222, whichever way you like to visualize it. 3/9 is, I think you guys can finish the pattern, right? 0.3 repeating. So 3, 3, 3, 3, 3, 3, 3. So 4/9, 0.4 repeating. 5/9, 0.5 repeating. 7/9 is 0.7 repeating. And that's something I want you guys to commit to memory, that anything divided by 9 is just that number repeating, that number repeating, that number repeating if you're dividing by 9. So when placing 1 7/9 on a number line, we go over to 1. 7 would be to the right of 7/5. So 1.5 is right here. The tick mark between 1.5 and 2 is 1.75. So if this is 1.75, then that means 1.7 repeating is going to be to the right of it. Yeah. So know your fractions to decimals to the nearest 0.25. Okay? All right. Letter D. What happens when we have a fraction that doesn't really hold to it any kind of specific pattern? By the way, it looks like my A is not where it's supposed to be. Remember, A was just slightly to the right of 1/2. Okay. When we're looking at -1 5/7, it's kind of tough because there is no pattern for the 7ths, so what I have to show you guys now is how do we just straight up turn that fraction into a decimal? So what is 5 over 7? Well, 5 over 7 is just 5 divided by 7. And if you remember anything about converting fractions to decimals or doing actual long division, that just means you put a 5 inside of the dividing box and the 7 on the outside. 5 inside the box divided by 7 on the outside. Inside divided by outside. And then all we got to do there is sort of say 5 is the same as 5.0, which means now we can talk about 7 relating to 50. 7 goes into 50 7 times, right? So it's 0.7 something, okay? So 7 times 7 is 49. Subtract the 2, and then you drop another 0 down. You guys might have forgotten about this over the summer, but manual division looks like this. Then 7 goes into 10 one time, and I'm done. I don't need to see any more information. Here's why. It's really close to negative 1.71, which gives us a clear cut, what's the word I'm looking for? Comparison, yeah, to 0.75. So it's negative, it's in this direction. Negative 1.75 is right here. That would be negative 1.75 because it's exactly in between negative 1.5 and negative 2. So negative 1.71 is not quite to negative 1.75. It's to the right of it as we're talking about negative numbers. So that's where D is. All right, then the last big concept I want to talk to you guys about is, what do we do with square roots? Good question, right? Well, here's the deal. Each one of these numbers on the number line can be written as a square root. Think about what a square root means. It means what's the number times itself that gets us to the number under the square root. So think about it. 0 times 0 equals 0. So the square root of 0 is equal to 0. That's what it means to be a square root. So then you could just go through the whole thing. What's 1 times 1? It's 1. So that number times itself would give me 1. And if we're going in the negative direction, I just put a negative in front of the whole thing. Let's move on to the next one. How about 2 times 2? That's 4, right? That means that the square root of 4 is 2. So this is like root 4. This is like negative root 4. And then 3 is equal to root 9. Or in this direction, negative root 9. 4 times 4, that's 16. Therefore, the square root of 16 is equal to 4. So we have something to compare to now. All these roots have been revealed. There's not much more to it than this. So when somebody asks you to put something like... Sorry, let me finish this first. When somebody asks you to put root 10 on the number line, you just ask yourself, I'm estimating where root 10 is. Where would root 10 be on this spectrum? Well, it's positive, right? So I'm going right on the number line. Here's root 9. Root 10 would be just to the right of it. Root 10 is just to the right of 3. So, root 10, right about here. I'm not asking you to think of it any closer than that. It's between 3 and 3 1/4 because it's so close to the 9 and so very far away from the 16. That's what I'm using to estimate that. So that's letter E right there. If that's where root 9 would be, then that's where root 10 would have to be. And then if we're going in the negative direction, I'm just going... Here's negative root 9. Negative root 10 is going to be just a little bit to the left of that. So here's negative root 10. Or think about it in terms of letter F. All right. Wow, that was a lot. I'm going to roll you guys through one more example, okay? This was kind of painstakingly slow, but I had to get all that information to you if I want you guys to make some progress. So let's do the next one. I know we're already pushing 15 minutes on this video. I'll try to move at a quicker pace for this next one. All right, here's example 2. So the first thing I'm going to do is I'm actually going to leave these guys on the number line to give us some reference point just in case a square root shows up. which it does on letter D. Sorry, once again, if you're confused about where we're at, this is example 2 on the 1.1 notes. Example 2, 1.1 notes. All right, so right away, I'm leaving these guys where they're at because what it does is it gives us a visual cue for where root 17 should be. Root 17 should be just a little bit to the right of root 16. So who's root 16? 4. 4 equals root 16. So root 17 would be just to the right of it. And then you're done. You don't have to do any work. You don't have to write out all that stuff that I had on the previous example. You just got to say, hey, root 17 is just to the right of root 16. All right, let's move backwards. Letter A. We've got a 9th. If you have something divided by 9, you know that it is that something repeating as a decimal. So this is 3.2 repeating. You've got to commit that to memory now. Anything divided by 9 is that number repeating. Additionally, you need to understand that 3.25 is the quarter mark between 3 and 3.5. So where would 3.22 be? Just to the left of 3.25. So that's where this one would be. Letter B is giving us the decimal right off the bat. Hey, we can do a lot with that. If they're telling us that it's negative 4.77, we go all the way left to negative 4.5, which is negative 4.5, to negative 5.0. Negative 4.75 is exactly halfway between. This is a little bit more than 0.75. So I'm going to put a dot right to the left of it because we got to go 0.77 over, not 0.75 over. So that's where B is. It's left of the quarter mark in between negative 5 and negative 4.5. I'm going to skip right to F because that's a decimal as well. Negative 0.48, okay? We're going to think of it in terms of negative 1/2 is negative 0.50. So if negative 0.48 is compared to negative 0.50, negative 0.48 is right of it on the number line, right? This is less than that. So the 0.48 is going to go over here because we're going in the negative direction. So that's where F is. All right, letter E. What I'm hoping jumps out at you at letter E is that you're seeing, hey, 13 over 27 looks like 13 over 26. And negative 13 over 26 is exactly half. So if we're talking negative 13 over 27, we're talking about it's less than 1/2, because to be half of 27 means you got to be 13.5. This is like negative 0.4 something. But that's kind of tricky because we're really close to 0.48. So what I'm going to do in this situation is I know that it's less than negative 1/2. Okay? I'm sorry. Here. Negative 13 over 27 is like negative 0.4 something. Since we already had a negative 0.4 something, we should probably figure out what the whole decimal is, which means we should just do the whole division. So, unfortunately, I didn't mean to do it like this. I'm sorry. But this F and E are really close together. So put the 13 divided by 27 in the box. Check it out. I'll do some quick math here so that we're not spending the whole time on the video trying to figure this out. It ends up being 27 goes into 4, I'm sorry, 134 times subtracting this gives us 22. Drop a 0. Does it go in 8 times? Does it go in 9 times? That's the real question. I'll try 8 to see what happens. This would be 56. Put a 5 here. 16 plus 5 is 216. Okay. It's 0.481. So it's more than 0.48 left. So it's a little bit left of f on the number line. That was tricky. I'm sorry, guys. I didn't mean to be this tricky on day one, but alas, here we are. All right, so that would be E. And then on letter C, my hope is that you guys would maybe be able to just recognize 2/5 right off the bat. This is something you should commit to memory. Okay? The fifths follow a very basic pattern because when you think about it, if I put them all over 10 by finding common denominators, it's 2 over 10, 4 over 10, 6 over 10, 8 over 10, and 10 over 10. So I don't know if you guys are seeing that just now, but I'm going to end the video on this right here. 0.40 will be just left of 0.5 on the number line. So 0.5, 0.4. It's bigger than the quarter mark though. All right. Hey guys, thanks for watching. Hey, this is going to be a relatively tough chapter, but it's still manageable if you guys work hard, watch the videos, ask questions in class, and make sure you get your homework done. So, thanks for watching. 1.2 coming at you soon.